I'm back with another domain and range topic. So we're working on this sheet today, domain and range practice day 2. You were given that on December 10th or 11th, depending on the day you had me. So very similar to last week with our functions graphs, although this time we have a few different representations. You have a table and a mapping. And we've got some application problems on the back, some contextual problems. So again, domain and range, how much are we using in the x value? Is it specific values because it's a discrete function, or what's the range if it's continuous? And same thing for range. So let me do some work on this and then I'll come back to you. All right, so the first one we're gonna take a look at is this table. A table represents a function because you have an input, you have an output. So it's important to denote which one is which. And this is a job, it's hours and pay, so I'm making some conclusions here. Maybe you have been working at your fast food job for a while, or maybe you're entry level in some landscaping, outdoors work, whatever. $10 an hour, 1 hour, $10, 3 hours, 30 hours, $10 an hour. The domain is the hours because time is in the independent variable, and how much you're getting paid is the dependent variable, your y. So I write it in this notation. This is not a continuous function. I don't have all the information, so I'm just going to use these. This mapping would be very similar to this. Now these graphs, you're going to go back to the boundary method, the Chinese finger trap. But this graph here is different. It's not continuous. It's discrete. We don't have all the information. We can assume that this is a quadratic function and it makes a parabola because you see that nicely U shape, and you see this vertex here at -4, -3. It's concave up, makes a cup. However, we don't have that, so we can't make assumptions that we don't know. Now, what I like to do before I do any of this stuff is label my ordered pairs, my x and my y. So I know my x and I know my y, and I use purple for my domain and y for my range. And I'm just going to list my domain and range like I did upstairs at the table problem. So I'm going to write all the x's, I'm going to write all the y's. That's it. Now, it's good practice to list these from least to greatest. As you can see, I did in the domain and the range. Now, you will notice there were 2 -1s and there were 2 5s, but because they're repeated, we don't need to write them twice. If you go ahead and do that, it's not wrong, but you don't have to show the same values twice. Now, is this a function? We had a number repeat. Think about it. 1 input, 1 output. Each individual x only has 1 output, and this will pass the vertical line test. So this definitely is a function. All right, so this problem here, we have FedEx, and with holidays, FedEx and UPS and all those guys are really important in getting us our packages. We are given a function, f of p equals p divided by 20, where p is the number of packages, and we know that in one day, FedEx cannot ship more than 6,000 packages, so that's 6,000 packages or less. So if we think about this, packages have to get put on a truck, they have to get delivered. So we want to know, what would the range of the function be? So to know what the range is, I should probably figure out what the domain is. So I know that domain based on how the function is written, because it's f of p, so f of the input, and the input is packages, that the input relates to domain, and the number of packages delivered is p. Now, what relates to the number of packages? It's the number of trips. So the number of trips would be my range. So you see I had to cross some stuff out because I made a mistake. But domain is the number of packages and range is the number of trips. So I'm gonna quickly, so now that I know domain and range, I can set it up. And I probably should have put a P there, but domain is the number of packages, so 0 to 6,000, and the range is 0 to 300. Now this next one, I'm not gonna give you too much information, but think of what squares are. And down here, I was given a domain and a range. So what I did is I used dotted lines to indicate when it was just a less than or greater than symbol to show that I have to put an open circle there and don't actually touch that line, and a solid line for when it was greater than or equal to or less than or equal to. I can make any graph, doesn't even gotta be a function because it doesn't specify as a function, that fits inside this box. So all that pink stuff, you can't go there. So you just need to set up your domain and range and then create whatever you want. Yeah, I would recommend using this method. So hopefully you guys got some help on all the different tasks. And if you don't, and you still don't know something, please ask for help. Or there's a lot of other resources out there, guys. I know my videos are pretty dope, but there's other people that make them too. So just look.